determine whether or not the vector force field is conservative. So we are given a vector force field in space. We have three components and we need to check if this is a conservative. For first, look at the domain of this force field. Everything's nice. That means all the points in the space, x, y, z, okay, everything R3. So the domain is simply connected, so we have no problem with that. And next we want to check if the curl of f is 0. If this is 0, then this vector field is conservative because the domain is nice, simply connected, and the curl of f, which is same as del cross f, is 0. Let's find this. For this del operator is just this cross product, so I, j, k. This del operator is just partial with respect to x, y, z. Then let's write down these three components. Z cosine y, x z sine y, x cosine y. Okay, now let me write in component form, by the way. So for the first component, for I, we delete the row and column containing I, so we go this way minus this way. This way means find the partial derivative of this with respect to y. Okay, minus this way, then partial derivative of this with respect to z. So with respect to y, so x behaves like constant, and derivative of cosine y is negative sine y. So negative sine y x. So negative x sine y. And this way means minus by rule. Now we need to find partial derivative of this with respect to z. So g x sine y is constant and derivative of g is 1. So it's just x sine y. Okay. Comma. And we don't have to do anything else because this is not 0. It's almost 0, but they are same. So they are same means this is not gonna be a 0 vector. To be a 0 vector, we have to have 0, 0, 0, all three 0. And if the curl of f is 0, and since the domain is simply connected, they should be conservative, but the curl is not 0, so f is not conservative.